In this video, we're going to finish up our review for Test 4 by looking at problems 24 through 28 on the review sheet. So let's take a look first here at number 24. Based on mortality tables, the probability of a 20-year-old male living to age 21 is 0.99. If the yearly premium of a $1,000 one-year policy on a 20-year-old male costs $25, what is the expected value of the policy from the insurance company's point of view? Okay. So, number 24. So, from the insurance company's point of view, there are two possibilities. The insurance company is either going to earn $25 on this policy, and that would be if the 20-year-old lives and doesn't die so that they don't have to pay out the claim, or the insurance company is going to lose $1,000. Okay, so again, this is because the $1,000 policy costs $25 that they're charging. Okay. Now, the probability that the 20-year-old is going to die and the insurance company has to pay out the $1,000 is going to be 0.99, which means the probability that the 20-year-old will live will be 1 minus 0.99, which will be 0.01. Okay? So the probability that the 20-year-old dies is going to be 0.01, and again that is coming from 1 minus the 0.99, and the probability that the 20-year-old lives is 0.99, and that was given to us. Okay? Now, when I say that the insurance company loses $1,000, that's not exactly accurate, okay? Because regardless of whether the 20-year-old lives to be 21 or not, he has paid $25 for the premium, okay? So what the insurance company will actually lose would not be $1,000. They would lose $1,000 minus the $25 that was paid for the policy. So 1,000 minus 25 is going to be 975, okay? So it's actually $975 that the insurance company loses rather than the entire $1,000. Again, because regardless of whether the insurance company has to pay out the $1,000 or not, the 20-year-old has paid $25 for the policy. Okay? So what I'm getting at is this. So there are two values that are going on here from the insurance company's perspective. Either the insurance company makes $25 or they lose $975, and since they're losing that, I'm going to write that as negative 975. Okay? Now again, the probability that is associated with that is, well, again, if the insurance company earns or makes the $25, the probability of that is going to be the same as the 20-year-old living. So that's going to be 0.99 probability. And the probability that the insurance company is going to have to pay out the $975 or pay out the $1,000 and lose the $975 is going to be the other 0.01. Okay? So we're trying to find the expected value. So we're going to take each value times the probability that corresponds to that. Okay? So in other words, I'm going to take the $25 times the 0.99, and I'm going to take the negative $975 times the 0.01. So if I bring in my calculator for that, 25 times 0.99, that is 24.75, or $24.75, okay? And if I take negative 975 times 0.01, that is equal to negative 9.75. So if I add those two things together, 24.75 plus negative 9.75, that equals $15. That $15 is the expected value from the insurance company's point of view. Okay? So again, remember to find the expected value, we take each value times the probability associated with that value, and we add that up, and that gives us the expected value. So in this case, the expected value is $15. So the insurance company is expecting to earn $15 for each one of these policies that they sell. So for every one of these $1,000 policies that they sell, they're expecting to make a profit of $15. Okay? Now let's take a look at number 25. So number 25, a card is drawn from a standard 52 card deck. If a face card is drawn, you will win $15. Otherwise, you will lose $5. Calculate the expected value of this game. So again, this is just another example of an expected value problem. Okay. So I'm going to make a table of the values and the probabilities associated with those values. Okay. So again, in this game, you're either going to win $15 or you're going to lose $4. So those are our two values that we're dealing with, $15 and negative $4. Okay? Now we win $15 if we draw out a face card. So the probability of drawing out a face card is 12 out of 52. And just to demonstrate that, I'm bringing in a figure of a deck of cards. So there are 12 face cards out of the 52 card deck. So the probability of winning the $15 is going to be 12 out of 52. And we could reduce that if we wanted to. Okay? Now the probability of losing the $4, well, that's if it's not a face card. Well, all of these cards over here, and there are 40 of them, are not face cards. So the probability of losing $4 is 40 out of 52. Again, we could reduce that if we wanted to. Okay? So we're going to take each value times the probability. Okay? So I'm going to take the $15 times the 12 out of 52, and I'm going to take the negative $4 times the 40 out of 52. If I bring in my calculator, 15 times 12 out of 52, that is approximately 3.4615. I'll round to 4 places. So that is approximately 3.4615. Okay? And if I take negative 4 times 40 out of 52, that is approximately negative 3.0769. So this is negative 3.0769. And so if I add those two things together, that will give me the expected value. So 3.4615 plus negative 3.0769, that is 0.3846. So if I round that to the nearest penny, that would be approximately 38 cents. So that is the expected value from playing this game. So each time you play this game, you would expect on average to win 38 cents in the long run. Okay? So if we played this game a large number of times, on average we would earn 38 cents each time we play that game. So a pretty decent game to play. Okay. Now let's take a look at number 26. You are playing a game in which 3 fair coins are flipped. If all 3 coins show the same, in other words, if all 3 coins land on heads or if all 3 coins land on tails, you win $5. Calculate the price to play the game that would make the game fair. Okay? So in this particular case, we are wanting to figure out what would the price of the game have to be in order to make this a fair game. Now remember that for us to have a fair game, the expected value has to equal 0. Okay? Now, I do want to point out a sort of a tricky part of this problem. Okay? So this is a game you're playing and you have to pay to play the game. Okay? So this is sort of like the problem here with the insurance. So the individual had to pay the $25 for the policy, and then that affected what the insurance company was going to have to ultimately lose if they had to pay that out. So we had to find the difference between what the person paid for the policy and what was actually paid out by the insurance company. So it's the same kind of deal. So like if you pay $1 to play this game, okay, then you're actually only winning $4 because you had to pay $1 to win the $5. And so that's a sort of a trick on this problem. Okay, so we're going to let X equal the price. And we're going to use that to figure out what the price would have to be in order for the game to be fair. Okay? Now, so if I think about the value and I think about the probability. Okay? So one of 2 things is going to happen. One, you're either going to lose the X dollars that you paid to play this game, okay, or you're going to win 5 minus whatever that is. Okay, so again, like if that was $1 and you lose, you're going to lose $1, so that would be -1. But if you pay the $1 and you win, then you actually gained $4 because you had to pay $1 to play. Okay, so our values are either going to be -X or 5 minus X. Okay, now the probability. We win if we get all heads or all tails, and we lose if we don't get all heads or all tails, and we're flipping 3 coins. Okay, so I want to think about that. Okay, I'm going to use a tree diagram. So I'm going to think about the first flip, the second flip, and the third flip. Okay, so the first flip would be heads or tails. That's like the first coin. And then the second coin could be heads or tails. And then the third coin could be heads or tails for each of these outcomes. We've done this several times now throughout this course. So our total outcomes are that we could get heads, heads, heads. We could get heads, heads, tails. We could get heads, tails, heads. We could get heads, tails, tails. We could get tails, heads, heads. We could get tails, heads, tails. We could get tails, tails, heads. Or we could get tails, tails, tails. So my point is that there are 8 outcomes that are possible. Of those 8 outcomes, there are 2 where all are the same. So all heads or all tails. So the probability of getting all heads, the probability of winning the $5, in other words, would be 2 out of the 8 possibilities. The probability of losing our X dollars will be the other 6 out of 8. Okay, so any of these would be losing. These two would be winning. Okay, so again, this was losing right here, and this would be winning. Okay, so our expected value, I'm going to take the value times the probability, and I'm going to add those up. Okay, so I'm going to take my value, negative x, times 6/8, and so that would be negative 6/8 times x. And I'm going to take my value, 5 minus x, times 2/8, and so that's going to be 2/8 times the quantity, 5 minus x. Okay? So if I add that together, I'm going to have an expression, negative 6/8 x plus 2/8 times 5 minus x. Okay? And for this, so this would be our expected value. And for this game to be fair, that expected value would have to equal 0. So I'm going to take the negative 6/8 x plus the 2/8 times 5 minus x and set that equal to 0 and solve for x. And whatever x is, that would be the price that I would have to pay in order for this game to be fair. Okay? So solving this equation, I'm going to start by distributing the 2/8. So I have negative 6/8 x. And by the way, I could reduce that, but I'm going to just go ahead and use it. 2/8 times 5 is going to be 10/8. Again, we could reduce that, but I'm not going to. And then I have minus 2/8 x equals 0. Okay? So if I have negative 6/8 x minus 2/8 x, I can combine that. Negative 6/8 x minus 2/8 x would be negative 8/8 x, which would be negative 1 x, plus 10/8 equals 0. So if I move the 10/8 to the other side, negative x would equal negative 10/8. Divide both sides by negative 1, so x would equal positive 10/8. And if we take 10 divided by 8, that is 1.25. So this is 1.25. So the price that would have to be charged so that this is a fair game would be $1.25. So if you pay $1.25 to play this game, then that would make this a fair game. You pay $1.25. If you don't get all heads, you would lose your $1.25. If you do get all heads, you would win the $5, which again would really mean you would make a profit of $3.75, and so that would be a fair game. Okay? If you played that a large number of times, then the result in the long run would be 0. You wouldn't win anything or lose anything, either one. Okay? Let's take a look at number 27. Number 27, we want to calculate B of 8, 3, semicolon 1/2. So that is a binomial probability that we want to calculate. So number 27, again, it is B of 8, 3, semicolon 1/2. So this is saying we're doing a binomial probability where we have 8 trials. The probability of success is 1/2, and we want to calculate the probability of exactly 3 successes. Okay? Well, our formula for that, if you will remember, is the probability of k successes will be the combination of n, the number of trials, taken k at a time, the number of successes time, and then we're going to multiply that by p raised to the k. P is the probability of success, in this case 1/2, and then we're going to multiply that by 1 minus p, that's the probability of failure, raised to the n minus k, that is the number of failures, power. So that is our formula for calculating a binomial probability with exactly k successes. Okay? So in this case, this is going to equal the combination of 8 choosing 3 at a time times p, that's the 1/2, raised to the k, that's the third power, okay, times 1 minus p. Now 1 minus a half will equal 1/2 as well. So 1 minus p is going to equal a half also in this case, okay? And in this particular case, n minus k would be 8 minus 3, and so that would equal 5. So that would be to the 5th power, okay? Now, if I do the combination of 8 choose 3, that is 56. So what I really have here is 56 times 1/2 to the third power times 1/2 to the 5th power. And incidentally, we could combine that to be 1/2 to the 8th power, but I'm not going to. So we have 56 times 1/2 raised to the third power times 1/2 raised to the 5th power, and so that is 0.21875. 0.21875. And I think usually we're going to be rounding that to 3 places, so if we round that to 3 places, that would be a 0.219 probability. Okay? So if the probability of success for each trial is 1/2, if there are 8 trials, then the probability of exactly 3 successes is going to be 0.219. We have one problem left, problem number 28. You are given a 5-question multiple choice pop quiz. What is the probability that you will answer at least 3 questions correctly by guessing, if each question has 4 options, A, B, C, or D? Okay? So the key to this problem is recognizing that this is a binomial probability. We are looking for the probability of at least 3 successes. In other words, the probability of answering at least 3 of the questions right, okay? Now, there are 5 questions on the quiz, okay? And each question has 4 options to pick from. So that means that the probability of guessing the answer correct will be 1/4, okay? That also means the probability of guessing the answer incorrectly is going to be 3/4, okay? So this is the probability of success. This is the probability of failure, okay? Now, if we're going to have at least 3 successes out of the 5 questions, then that means we need to find the probability of 3 successes. We need to find the probability of 4 successes. We need to find the probability of 5 successes and add those 3 things up, and that will be the probability of at least 3 successes. Now again, this is a binomial. We have 5 problems that we're picking from, so we have 5 trials, and the probability of success is 1/4. So this probability of 3 successes is a binomial probability with 5 trials, 3 successes, where the probability of success is 1/4. This would be P of 3. The probability of 4 successes is a binomial. It is 5 trials, 4 successes, and the probability of success is 1/4. The probability of 5 successes, again, is a binomial. So it is 5 trials, we're looking for 5 successes, and the probability of success is 1/4. So we're going to need to find each of these 3 things and add them up, and that will give us the probability of at least 3 successes. Well, using our formula for binomials, this is going to be the combination of 5 choosing 3, 5 choose 3, times the probability of success 1/4 raised to the number of successes power. That's going to be the third power if k is 3. And then times the probability of failure, that is 3/4. And the number of failures will be 2, because if there are 5 trials and 3 successes, that means there are 2 failures. So that 2 right there is coming from 5 minus 3. Okay? So this will give me the probability of 3 questions correct. Okay? Now, what's the probability of guessing 4 questions correct? Well, that's going to be the combination of 5 choose 4 times 1/4 the probability of success raised to 4th power, the number of successes power, times the probability of failure 3/4 raised to the number of failures power. So that's going to be 1. Now that if we have 4 successes, there's going to be 1 failure. Okay, so that's coming from 5 minus 4 right there. And then last but not least, we need to calculate the probability of guessing all 5 correct. So that will be the combination of 5 choose 5. And then we're going to have 1/4 raised to the 5th power. And then 3/4 raised to the 0 power. So again, that's the probability of success raised to the number of successes power. If we guess all 5 correct, then we will have 5 successes. And then the probability of failure is raised to the number of failures power. Well, if we have all 5 successes, then we have 0 failures. So that's coming from 5 minus 5. Okay? So now I just need to calculate this. I'm going to start by calculating the combinations. So 5 choose 3, that is 10. So this is 10 times 1/4 to the 3rd power times 3/4 to the 2nd power. And if I do 5 choose 4, that is 5. So this is 5 times 1/4 to the 4th power times 3/4 to the 1st power. And then the combination of 5 choose 5 is 1. So that is 1 times 1/4 to the 5th power times 3/4 to the 0 power. And incidentally, 3/4 to the 0 power is 1. So we really just have 1/4 to the 5th power right there. So now I'm going to calculate each of these. Okay? So 10 times 1/4 raised to the 3rd power times 3/4 raised to the 2nd power. That is 0.0879 if I round that off to 4 places. So 0.0879 is approximately what that will be. Let's change that to approximately equals. Okay? Plus, if I take 5 times 1/4 raised to the 4th power times 3/4 raised to the 1st power. And again, I really don't have to put that 1st power there because that would just be 3/4. So that is going to be 0.0146 if I round to 4 places. Okay? And then last but not least, I have 1 times 1/4 raised to the 5th power times 3/4 raised to the 0 power. And again, I really wouldn't have to type that 3/4 to the 0 power because that's really just 1. So it's really 1 times 1/4 to the 5th power times 1. And that gives me this scientific notation. Now sidebar for just a second. I have 9.765625 e negative 4. So that really means 9.765625 times 10 to the negative 4th, which means this decimal point moves 4 places to the left. So if I move that decimal point 4 places to the left, I'm going to need 3 zeros behind the decimal point, then 9.765625. So if I round that to 4 places, the 7 is going to make the 9 go up to 10, so that's going to be 0.0010. So this probability is 0.0010 approximately. So if I add that up, that's going to be 0.0879 plus 0.0146 plus 0.0010. That adds up to 0.1035. So this equals 0.1035. And so if I round that to 3 places, that would be 0.104 approximately. So if you are given a 5-question multiple choice pop quiz, the probability that you will be able to guess at least 3 questions correctly is going to be 0.104 if you have 4 options for each question. So about a 10% chance of guessing at least 3 questions correctly. That finishes the review for Test 4. Good luck on the test.